lines for the chassis work. Please take it away, Manju.
Yeah. Hello everyone. So some of the review comments, most of the review comments as sent by Anshu in the meeting minutes last week have been updated. So mainly we've updated the sections where the approach for axing internal management versus external management, it's mid-plane Ethernet versus external management, the approach one, so that we have updated, and rest of the review comments with respect to DB schema and for chassis D related have also been updated. So the next half an hour to 45 minutes, I want to focus on couple of peripheral management pieces so that I get feedback from the community. So we'll cover PSUD and the thermal cuttle D.
Sorry, just one quick thing. Yeah, so I looked at the updated the diagrams and all that you updated. So how about the comments like which I kind of published last night or today morning? We plan to take it up later, or you would take a look later online and then kind of update it.
So if we have time at the end of our, so we have an hour. So if we have time before that, let's review those comments. If not, we can take it up offline. But I think it's important for us to go through these couple of peripheral management processes, the changes that are involved.
Sure.
Okay. Please feel free to take an hour and a half for your discussion. It's all right. 30 minutes for going over the plan is fine for me.
Okay. Yeah. So with the PSU, so what we want to kind of the requirements and the scope would be limited to, we're not planning to do kind of an active telemetry kind of an approach to get the per second or per few seconds power usage, but the scope is such that each line card, each SFM, each fan's power requirement per chassis would be known upfront. It is vendor specific, and based on that and the maximum power availability from each PSU is also known upfront. So we are proposing like a simplistic static algorithm where the power available versus the power required will be kind of monitored, and in case we kind of are not, the power availability is not there, we can take action in terms of either so some platforms probably have like a master PSU LED which we can set to a different color, so that can be an indicator, and of course syslog is the other indicator to say that we've exited the power availability. Right, so the proposal is that PSUD in its loop will be calculating the total capacity available from each PSU versus, into the number of PSUs that are present and has a valid status. Right, so from that we get the total available power. The PSUD also subscribes to events that are published by chassis D to get to know about the up and down events of the line cards SFMs. So from that it is able to calculate the total power that is used. So we have the total available power and we have the total required power or total used power, and from that we will kind of provide indicators that we are kind of running at normal power requirements, we are running at like a low power reserve, and once the used power kind of exceeds the total available power, we can say there's insufficient power, and these will be syslog. In our specific platform, we have a separate master LED for PSUs. So that is again vendor specific. We will call that API with the right LED settings. So the vendor can, of course, set the LED. Any questions here?
So yeah, there is no new API added here, right? It's just only the we are saying that how its algorithm is changed to accommodate line cards and the PSUs itself. There is no enhancement to the APIs. We thought the existing APIs would work fine.
So one question: the amount of the power that a line card needs is supervisor aware of that already, or is it fetching from a remote LC?
So, so in the chassis.py, it's a static number. So based on the type of line card, we can record it, right? Like all the constants we record. And of course, the type of line card can be fetched dynamically. That is available in chassis. So when the event is published, we can always go read the chassis table. So for a slot, we will know the type of line card, and from that we should be able to get the power.
Yeah, so that POI is vendor specific, right? So the PSU.py for a line card.
Correct.
Yeah, that's right. That's vendor specific, but no matter what the state of line card is, whether whatever be the booting stage, the expectation here or the flow wise, it is something like the supervisor or a CC would figure out a remote line card, type its variant, and fetch the value from the PY, right?
Yeah. So you can have, yeah, okay. That's right. So we'll have the type published, yeah. Some of these are basically configuration. We don't expect the operational model to have a real dynamic line card, but yeah, it can be extended. But right now the design is assuming that the line card is upfront known, the type is itself known. Yeah, but you can query the chassis.
Yeah, type is somehow supervisor will figure out the type regardless of the state of a remote line card.
That's right. Yeah,
that's correct.
Yeah.
So we are not, and also that to mention here that, right, we are using the same PSUD to even to manage all the PSUs. There could be some n number of PSUs because this chassis is a modular. Primarily, that's a difference between the SONiC current architecture to the new chassis architecture. The same PSUD will take care of all the PSUs because we didn't think that we need to have a PSUD per PSUs. Number of PSUs plugged in, because that might be quite a bit of changes. But our proposal here is to just extend the existing PSUD, a single PSUD, to take care of all the PSUs as well.
Correct. But then should it be similar to like to some extent in a fan algorithm? Because in fan part I saw that there's a policy file kind of a defined. So I think that is kind of a good thing or perfect in a way that a vendor is providing a policy file, meaning on policy A, action A, policy B, action B. And this is published up into the thermal control daemon. And thermal control daemon simply acts upon the published policy file from vendor. In this case, this final segment where insufficient power or running on low PEMs or PSUs, that kind of a policy to come from the vendor. Is that right? Should it be that way?
So the policy, yes, yeah, it is vendor specific, and also it's a configurable thing, right? Like in a SONiC, the policy file is kind of, it's not a really config DB, but it is that operationally somebody can keep their own policy file. So answer is yes.
Yeah, correct. Yeah, policy file. So should this diagram be enhanced to support that policy thing?
So that is on the thermal part LD, right? In this here, Manju, sorry, go ahead.
Yeah, no. So Sham, are you saying that currently in the thermal policy.json, we can even specify like PSU absence and all that, and the action that can be taken? So
yeah, I'm saying, yeah. So see, again, the last segment is, I feel vendor specific. Okay, these many PSUs, or based on this supply, this feed, system can still run. So should all this information come from vendor because it is very chassis specific or a platform vendor specific, and then this PSU daemon, which is residing as part of PMON container, would take action based on that policy file.
So right now, that's what we haven't, at least we haven't scoped that part where we'll have like a deep policy implementation, and we are just saying that um, on a high level, the requirement is just to say that there's available power versus used power, and as a first revision, right, this is what we are proposing. And what action needs to be taken, of course, we'll provide an API where the vendor can choose to take action, right? So we are just going to say that this is the available power, this is the used power, or we are going to publish these states. But we will be calling a vendor specific API based on which the vendor can choose what action to take.
Yeah, I think to answer your question, the policy can be little later. Right now, we are saying that this is sufficient to take care of it.
Yeah, I got it, because I was just going to the next step because I was just trying to compare it with a fan or the thermal control daemon. So that's the reason.
Yeah,
that's fine. We can take it up later.
Correct. So we thought maybe it can be a step. So right now we didn't see the requirement to have like a policy and action file.
Okay. So one extension of this, I think this is fine for now, because usually this power is very static in a way. But I mean, down the line, maybe like currently it's come from Microsoft. There is a dynamic power budgeting or a requirement, which is more granular in the sense that as and when you power up the components, allocate power accordingly. For instance, here it is very clear. Okay, line card needs 1500 watts. Fine, but that 1500 means it is fully up and running with a so and so traffic. However, dynamic power budgeting is something different, where you allocate as and when it is required or requested. So, I mean, tomorrow should we take that into consideration and have a separate section later for that?
Yeah, that's right. So the dynamic power allocation is a separate, it's an enhancement from here. The baseline is we are trying to enhance just initialization and minimal management, like more like a static, as I said, this is static power management. Traditionally, for dynamic power management, it can be an enhancement on top of it. And we didn't cover it here as we are not scoping that here. Yeah. But we can take it up separately as an enhancement on this.
Yeah, definitely. It would be a later thing, not for currently or now.
Yeah.
Okay.
That makes
That's
sense.
a good point. Yeah, good point that we will scope it out also. Yeah, I think we did think about a little bit, but we didn't cover here because too much to talk about otherwise. Yeah, that's the biggest problem.
Got it.
Yeah. Thanks. So I'll make a note, and maybe we can say that dynamic power we will bring it up at a later stage as a separate HLD or a PR. So if there are no more questions on PSUD, I would like to spend the next few minutes getting some feedback from the community with respect to thermal cuttle D. So in bits and pieces, I think we've discussed the thermal cuttle D approach. So there is the monitoring piece, which happens on the line card and the control card. That happens very similar to how monitoring happens on the pizza boxes, right? So from the functional requirement perspective, we are saying that we have sensors on the control card, line card, and SFMs, and all of these need to be monitored, right? And all the thermal sensor info, although will be distributed, it needs to be in one place on the control card, because the fan control is on the control card, right? So also are saying that the current thermal cutlery is flexible enough such that the fan algorithm can be implemented as part of the platform, or it can be implemented as part of the existing thermal policy infrastructure. Right. So those are the high-level requirements. So what we saw was the monitoring piece as such probably can stay untouched, where all the thermal sensor info can be monitored locally in each line card and be updated in the local Redis DB, right? So for the control card, the temperature sensors will be on the local control card Redis DB. On the line card, it will be in the local on the line card, right? But for the fan algorithm to be implemented, we spoke about each line card reaching out to a global DB to update the thermal sensor information, right? So just to kind of pictorially represent it, right? So I want to say that, okay, these are the two approaches, right? So we've been talking about it and it fits very well in the thermal cutlery example, right? So the two approaches would be the disaggregated DB, where the thermal cutlery can reach out to each line card's local Redis DB, pull that information and store it in its local DB so that it can be used by the thermal policy. Or the second approach would be that thermal cutlery on each of the line card and thermal cutlery on the control card will all push the information to their local Redis DB on the left and to a global Redis DB on the right, so that all the information is in one place. And when the thermal policy is run, when they collect all the info, they all of them need to just collect it from the global Redis DB. Right. So I want to get, so we are kind of, kind of hinting towards option 2. So I just want to get feedback from the community to see if, that is like the approach that, everybody likes, and if there are any gotchas with that approach.
Yeah, actually that is good. Yeah, I put few comments on that, but yeah, at least I am inclined towards option 2 because there are some obvious advantages. It's like one global DB catering to all remote cards, plus remote card, line card, any update is known onto the line card, known only to the line card, and it would publish as and when there's a variation or a change at the line card. So that way you have one holistic view as this yellow global DB.
Yeah.
Yeah, and definitely it fits quite well with the fan algorithm, thermal control daemon referring to this DB.
Correct. So one pitfall which we could see was, let's say a line card got pulled out, right? So one change we could see in thermal cutlery is now the global DB needs to be invalidated, right? So that particular table for the line card needs to be invalidated. So that thermal cutlery should kind of, take care of that too. Or that's what when the policy runs, it should be able to query saying that what are the valid line cards that are online, and only then go and access the DB from the data from the global DB.
But then one question, won't the cleanup or keeping the global DB up to date or sane would be the task of a chassis D? Because per previous discussion, chassis D is catering to eventually it would cater to removal insertion of a card or a card going faulty stuck. So if chassis D takes care of that and a global DB is in a sane state at any given time, then a recipient like a thermal control D would always be okay.
So chassis D as such,
there is two state, right? So chassis D says line card up or down, for example, right? Or present or not present. I mean, up and down is basically it's a kind of present or not present, because up and down it doesn't actually query the operation state of it as such, like completely up and down. So you know that it's not there or it's pulled out. However, that what it previously at the time, let's say time 0, some information got pushed to PMON from line card to a control card, global Redis DB. At least in current SONiC, nobody cleans up when line card goes down. That state is still there. For example, previously it was publishing some information saying that this is the temperature it was reported, like maybe 100 degrees, and nobody cleans up until otherwise you take care of it, saying that okay, now current is that line card is not present, hence we are not taking that 100 degree. Otherwise you will be accounting that as well. So
correct.
So
that's
right now that's the problem with option 2. It is not applicable in case of global VOQ DB in another document which we talked about for other things, but this is very specific for platform monitoring. So that's the reason option 1, when we initially proposed, we thought option 1 was better, because then we don't need to worry about, because we directly query the actual information what we wanted it. If the line card is not there, then we will not get any data. So it automatically takes care of saying that there is no line card. Here, the information is there, that information can be stale. So that stale information has to be accounted in some other way.
Correct.
So that's platform. So we will go with option 2. We are also kind of liking it, simply in line with every other options, like the VOQ DB kind of logic. But here we will, so option 2, and if something really, other than that problem, we don't see anything big significant, but that's a big problem in a way. If you think about it, could be a lot of stale information. We don't know when it got updated last, right? Like,
so one thing what we did discuss was, so thermal cuddle-D can subscribe to line card up and down events from chassis, right? Because chassis is updating a database, the local Redis DB with the line card state, right? So if thermal cuddle-D, the thermal manager part of thermal cuddle-D was also running a loop subscribing to those events, right? Then you have that state as well. So in thermal cuddle-D.
But just one thing, up down you are referring to present, not present. So think of a scenario like if a remote card is present, like a line card, but it is shut down for some practical reasons. It could be anything. Then even then this DB should be in a sane state, right? Because the card is present, but it is in a shutdown or a powered off state.
So it operates. If it is shutdown case, we assume that there is a graceful, deletion of the information from the global DB, right? When update happens, so when the line card is gracefully shut down, no problem, because the PMON process from line card would have removed, assuming that we removed the entries, right? Saying that whatever information published. But in case if it was not a graceful shutdown, sure, the line card can be present. But we were in the situation where we cannot differentiate now. That's the reason we were thinking that the option 1 is better. But we are okay with
we can discuss this. This is a doable. Eventually, one has to do this cleanup, but other than that, this fits better, right? In a way.
Just a suggestion. In the global Redis DB, right? Let's say there's a new table for the control card that owns the table is owned by the control card, which indicate what are the present line cards inserted. Hello? Yeah. And then also the control card should also update what are the line cards that are online, right? You don't want the chassis D to go invalidate line cards information, because what if the line card is in the process of coming up and updating it? Then there's like 2 writers, and it's gonna be conflicting. Their timing is gonna be, tricky. So for process like PMON, which need this information, they will always check against the chassis DB, global DB, and say what are the ones that are up. Then access those information. And for those who are not up, don't access it. Assume it's whether it's present or not, it's not up. Don't pay attention to it.
See, yeah, I mean that's the approach, right? But ultimately, there's a problem in this case that both information can be disconnected to some extent. They may not be in sync. So in one way, we're ignoring it. In other case, we should not ignore it. Kind of situations where the problem is option 2. For example, as you said, like line card can come up. There could be something which a temperature reporting, but it's never come up from your present point of it. So it is important that you read the local release DB data, because that's what we think it's the ultimate source of truth. But the source of truth here is that even though global release DB is there, but it's not really a source of truth, because we are thinking now that, oh, that could be that stale information. Then we are going in another channel to get the data, and that can lead to a data inconsistency problems.
How can you tell it? Yeah, how can you tell if the line card is healthy? Somebody has to make the call, right?
Correct. Yeah. So we can tell, like, so that logic. Let's say there's a table called line cards up or down, separate table kept by chassis D, and line cards are pushing into its own information to separate table. Now that table, you're saying that the data in the table, the line card specific table, is only valid only when the chassis D says the line card is up. But that's where we are saying that, since that could be the challenge if chassis D is trying to converge in a mechanism where it is, but instead of directly polling it, we can assume that that channel is ultimately is a source of truth, right? So that's a choice we make it, but let's go with option 2, then we can revisit it simply because the option 2 is a simplified version of it. It fits with the VOQ DB channel as well, because anyway we have a configuration. We don't need to have a discovery process. Here in option 1, there's a challenge for us is the discovery process. So what we are saying is in option 2, it is a vendor specific implementation to make sure that some sort that when the data is ready to be consumed can be done inside the vendor specific PMON code. Yeah.
So I feel like eventually when we will cater to the fault management scenarios, this model would definitely cater to the remote LC state, booting stages all the way to the operational. And once it is operational, then that is the time the card is worth using from this DB. The data for a remote card is worth referring to from this DB.
To add to that, I think this intelligence should be there in the platform APIs itself, I think, right? Because instead of each module polling or anything like that, if you can make this intelligence as part of the APIs, so that it checks the state of line card before accessing it, so it will be like unique.
I see. So the API, we specifically the API here, we are saying that there could be n number of information, right? There's not specific to one information. Here, the temperature information. There's so many sensors. Mainly it's sensors, but we are not limited to know that today only temperature, and it could be something else. But we will take a look at that. That might be a little comprehensive effort, right?
That's fine.
So
I think initially you mentioned there would be a state maintained of a remote card on the CC or the supervisor. So I am of the assumption that it would cater to the latest greatest state of a remote card.
Yeah, I think we should make sure that. I think there should be some sort of heartbeat. Okay.
Correct. So we will make that. That is definitely that heartbeat and other mechanisms, the side channel registers or whatever PMON can provide. But this option, Manju, can you go up? These are for the sensors, right? How we are going to update the line card information to the global DB here, right here. So mainly for in terms of pushing the sensors data and the temperature information and any other information to the either pull it or push it. If we do basically update to the global that is DB, then the state of that is such a way that we have to make it. So there should be a monitoring and who cleans. I mean, we cannot write. There cannot be two processes writing the same table. Then it means that there could be a problem. But how do we do the API? We didn't think about the APIs. We will think about that maybe next. We will update you on the maybe next sometime.
So I mean, right now that's what, right? So the chassis D, as we discussed, right? So it is the chassis D process is writing to its local Redis DB, and that has the state of. We did mention that we will have some monitoring, maybe via mid-lane Ethernet, and so it will give the state. So that state is available on the local Redis DB of the control card. right? So it knows whether line cards are out. Right. So all we are saying is now in thermal cuttle D, how do we get that state, right? It has to be only through either subscribing for the line card up or down events from this local Redis DB.
Yeah, but I'm just thinking like thermal control D is just one recipient at the moment. Maybe you might have thought through, or there could be, let's say, LEDD or something else in the
So all of
future.
them have to subscribe to line card up and down events, right?
Correct.
Because yeah.
Yeah, so the intent or the goal eventually would be to make a control card aware or a PMON aware of a latest greatest state of a remote LC.
Correct. Even for PSUD, so which is what I was kind of alluding to here. So the up and down events of line cards and SFMs has to come from Redis, and who is pushing those events would be chassis. So chassis would keep pushing state change on the Redis DB, and all I think going forward we'll have this requirement where all processes will have to kind of subscribe to these up down events of line cards and SFMs from the Redis DB.
Yeah, the difference is whether each of these processes, I think probably that's what I think Sham also is pointing to, whether each of these processes like PSU or thermal control, each of them subscribes to all the Redis DBs in different line cards, or is just one process like the chassis D who takes care of that, and that is available locally, so that the local guys can talk to the local global DB to see the status of line cards.
Yeah. I think that we are proposing that second one.
The latter one, yeah.
The latter one, yeah. So the chassis D will be.
Sorry.
Chassis D will be the calling the PMON API. We are given a couple of APIs for chassis D, which will return the status of the line card. So we could, vendor can implement very specific implementation of per chassis basis, because there could be some mechanism very specific to the vendor platform to tell the line card is healthy or not healthy. And report it to the chassis D, and chassis D will set the state, and that's where the show module state will show all the modules or line cards or SFMs or all of them are healthy or not. And from that state where every other process can subscribe and check healthiness of each and every component before accessing the data from that component. If that component says not alive, and that data could be the stale data, you can ignore that. So that's what we are saying. It's kind of a little different than the current PMON design, in the sense the previous PMON design. PMON is simply to query information on demand basis and act on it. It's much simpler. That's option one. I mean, much consistent in a way, because you're directly querying the information what you wanted it. That query can be over Redis, or it can be over registers, or it can be over PMON APIs, right? So those are the options, or SysFS options. But the option two is kind of going slightly different approach, that it's kind of distributed now. I mean, everybody asynchronously updating it and somebody acting upon it.
Yeah, I think so, sorry, one point here. Option one won't suit, because if I got it right, you are constantly polling or making repeated periodic calls towards a remote LC. Is that right?
Via PMON APIs. I mean, we can say yes, exactly. So we say that we will give a PMON API for each and every process, so that, okay, get the line card information, right? So now that implementation can go subscribe from Redis DB, or it can go implement via registers, or like per platform implementation. Reason being, we are saying that is better in a way, because then you have multiple choices, right? You can to implement it. So it is up to the platform to, you could still read the line card information even without Redis, because there are chassis which has a capabilities to read the line card information without having any IP connectivity or Redis DB. You can have a registers to read the information.
Yeah, but sorry, but that would be very like going over the platform vendor path, right?
Correct, exactly. So that's the current design, right? That's a single ASIC SONiC design. That's option one. If you look at that reason, we kind of proposed first one as option one, because the previous meeting, then we got option two as option. So we'll go with option two, what we are also saying. But only thing is, we have to list out the negatives and positives of each other, and we make a conscious decision right now, so that.
Yeah, so fine. Okay, option two, I was a little confused with your last couple of statements. My thought is chassis D would somehow help maintain the latest greatest state of all remote line cards and publish it somehow into the global DB. Now, all recipients, be it thermal control D, PSU D, LED D, on the PMON, on the supervisor, would simply listen to that DB. They can have a notification registration mechanism. So now this all handshake exchange resides within a SONiC layer or a PMON on the supervisor. That's it. You are not going to the platform. Only chassis D is kind of doing whatever best is required to get the latest greatest state. In that case, whether it takes help of an Ethernet channel or the platform vendor, that can be figured out, or you can have all possibilities.
So that is common in the option 2. What you said is it is not option. I mean, option 2 has more than that. What you said is it is there in both cases, option 1 and option 2. The chassis D design is that it gets the information about line cards and keep it in the local release DB of the supervisor card or global release DB of the supervisor card. It is keeping there on the supervisor, right? However, for a thermal cartel D and fan D and LED Ds, either we can go and read the information from a global release DB for line card information, or we can go PMON API way. So in option 2, we are saying that we'll go global release DB way, so that we expect line cards to push the information up to the bottom up to the supervisors, rather than a supervisor going and directly subscribing to the each and every line cards. So that's the only difference between option 1 and option 2.
Yeah. Okay. Got it. Yeah. Thank you.
Okay, so does it sound reasonable? So we will go with option 2, and the source of truth would be chassis D for line card status, right? Hello.
Yeah, I could hear.
Yeah, that's fine. Yeah.
Okay. Yeah.
Go ahead.
So I think that is pretty much it. So we did kind of cover. Want to at least mention that with transceiver D and LED, we tried a slightly different approach with respect to the multi-ASIC support, where we had multiple threads, each representing a namespace. But I think we discussed this as part of the multi-ASIC PMON changes, and so we will take whatever is available on the multi-ASIC changes for the pizza box. So that will fit in well with the chassis approach as well. So we can skip these two sections, the transceiver D and LED section. So this pretty much kind of covers what requirements and proposals we had in terms of PMON. Anything else we want to discuss, we can take it up, or we can pass the control back to Anshu to discuss rest of the stuff.
So one quick thing, the post transceiver D, when you are referring to LED, that is a optics interface transceiver D LED, right? Front panel ports LED, right?
Correct.
Okay, then do you have a separate section for the board and the chassis LED?
So that is
actually,
going to be that's kind of, we didn't put that LEDs as a separate operational, I mean, kind of blinking. I mean, via PMON, but that's a good point.
No. So how it covers it is so like fan LEDs and stuff, right, are controlled by thermal cuttle D. So chassis D was the placeholder, which would so board is still the line card status, right? So would that kind of fit in well in the model? Chassis D setting the board LED and the chassis LED?
I think so, yeah. Because see, what I came to know so far is LED is more with respect to what is here, meaning the front panel port LEDs.
Exactly.
However, there is no such process yet, or maybe I think this is what Joe updated once, that there has to be some process which would cater to a board and a chassis LEDs. These are on the board, which are visible from outside. These are those LEDs. Yeah, so I think to me, a chassis D would be a right fit for this, for the management of these LEDs.
But wondering, why do you wanted to? I mean, we thought those are platform drivers will set the LEDs in accordance to the I mean, there is no there is no separate information which needed for that purpose to set that board or LEDs, right? It will be done on the driver level of the platform. Correct. So in that case, I was saying that, for example, if you have a fan, I mean, if you have something on the control line card, some LEDs indicating some sort of temperature high, let's say, for example, it blinks red or something. All those will be done the temperature reading within that line card, and the driver portion will do that automatically, right? There is no monitoring. There will be a monitoring. We can query. That's a status query we are saying. We are not querying LEDs per se, right? The indication is per platform logic, right? Not everybody will have unique common LEDs anyway.
So basic question that I have is, would there be any show LED CLI to display the state of board LEDs and chassis LED?
No, we didn't. At least we don't think there is. I mean, we have a status to say that operationally up or present or not present that state machine, but it doesn't cover LEDs in that combination, right? If it is present means LED can be off, or it's up to the platform very specific implementation, because I don't know whether we have a such a commonality in across all the chassis. So I would expect a platform driver to initialize the right LEDs. For example, some chassis, as I said, example, the temperature. A line card can have a temperature indicator, for example, which is really running hot. That is very specific to that chassis, and it will set the LEDs in according to the operational hardware operational model. It can only do red or off, right? Let's say there's no green at all, or it could be green. So all those things logic is a platform vendor driver code, either kernel space or user space processes.
So I think logic is vendor specific, Suresh. You're right. So even like a fan has these APIs of like, get LED color and set LED color, right?
Actually,
So,
yeah, that is all fine. Eventually, platform would help you set and get, because platform knows about its drivers and help do the job, get the job done. However, like think of a scenario, you have a status LED, simple status LED on a LC and a supervisor. Now possibilities are, it would start from red, it would start from no color to a blinking red to a blinking yellow all the way to green. So these are the possibilities, but these possibilities indicating the booting up stages all the way to green, meaning now the SONiC is up and running to whatever expectation is. So a basic question is like, how do we gel all these things? Because the driver can do, or a platform can do what it is asked to, but if the engine or the control is with the SONiC or a PMON, then how do we balance that out?
So okay, so what we are thinking, we can put a chassis as a placeholder for now, but that scope can be a because when you said example, the SONiC up and running means a lot of stuff, right? To control LEDs based upon SONiC up and running is it's too up. I mean, the SONiC to come in, there is multiple ASIC instances to be started. There are so many stuff, and to inform LED to turn on that time, it means that platform is trying to do a little bit more than probably lot of state machine in that case. To keep it simple, for now we are thinking that initially, I mean, all things are initialized is LED state, some extent are reachable, healthy kind of thing. Healthy means it is operationally working, but whether the stack are up or very specific beyond the driver knowledge base, If it has to obtain via Redis, that's something we can take it up as a separate item.
No, so when I meant the chassis as a placeholder, right? So each vendor has to implement their card.py, like psu.py, right? They have to implement it, and where the state gets published, right? So published as in the chassis D will call that API saying that this is the state, right? So there you can kind of have your logic to set the LEDs, like how the fan LEDs are set right now. So right now the state could just be online, offline, but going forward, let's say a few months down the line, we provide more granular states, so that can reflect it.
Yeah, because see, in a disaggregated chassis, right, we don't capture booting because the booting is asynchronous event. The supervisor will not even know the line card is booting because the booting is not in help with the supervisor. It is separately booting. The line cards are booting asynchronously all by itself.
Right.
So there is no, I mean, when ONI is installation happening and ONI booting, there is no mechanism to say that what state is line card. Line card, I mean, the supervisor can tell the line card %, and if Redis is reachable, then it can say the Redis is running. And that's about it, right? Those are two different state, basically present or not present, and reachability is there. The IP midplane reachability is there. Midplane reachability means that it could be that it is able to reach the midplane drivers are up, not necessarily Redis is running, right? That kind of state is not a PMON state. From a line card point of it, booting, we are not covering in a supervisor state machine at all. At least that's our proposal, because with the disaggregated chassis, line card can have a completely boot and operated as independent piece of box.
Yeah, okay, but I think we mentioned that maybe we would cater to this thing, right? Eventually, LC booted up and then maintaining the state on the LC with respect to this option 2 discussion, right?
Correct, yeah. So that will be there, yeah. That state machine is same. Basically, we are saying that the midplane reachability exists and it's reachable or not. That's a state. It's reachable or not is a state, rather than it's booted or not.
Okay. Okay, I think there may be more use cases. We can discuss them later or jot them down, because there are other things which comes to my mind is like this. So like there's a fabric card and a fan tray. So fan tray absence presence or a fabric card status on a fan tray. I mean, there could be a mix of those. Meaning eventually when the SONiC layer or a PMON is aware of it, then it can ask platform to set the LED accordingly. Something on those lines.
So that already happens, right? That happens today, at least for fans.
Sorry, what happens?
So as part of thermal cutlery, where it kind of monitors the fan presence and fan state, it goes and sets the LEDs for the fans. Fan state, right?
Yeah. Okay, yeah. So I think in some model or some vendor, they have the layout is such that there are fabric cards and such LED status is maintained on some other board or LED like a fan tray for space and all space constraints. In that case, you have to do some kind of a math and update whoever is managing it, like a daemon, and then daemon will ask the supervisor to set or get the LED.
Oh, so that could be the based upon chassis D state machine then. Yeah. So chassis D publishing that. Yeah. So then, so that daemon, yeah, you could make a chassis D itself to do that work as long as we get the state, because anyway we are getting the state. So, but if that LED is running, for example, if that, but is that supervisor can set the LEDs, or is it separate card is setting that LEDs?
The supervisor can set it, because other than remote LC LED, supervisor can set. Actually, supervisor can set remote LC LED, but usually it does not, as long as the LC is up.
Oh,
but
so
supervisor is something, which can reach any card in the chassis.
Okay, I got it now. So that LEDs, you're right. So that, let's say if you have array of LEDs, basically saying that in a supervisor or wherever it is, which is not controlled directly on the LCs, if that LEDs can be set by supervisor, then that chassis is a placeholder. Yeah, maybe we'll add that. I think Manju, I think we can add that to cover that.
Yeah, such kind of scenarios we can add. We can come to that later. But as long as we have a section and a to do, we can get back to those things.
Yeah. Okay.
Yeah,
that
to,
API will keep it.
Thanks.
yeah, to add to
thank
that, so there's a parallel activity going on for the system health check. So I'm seeing, I've just pasted a pull request for that. So there are some activities going on there where we add the board LEDs and things like that to the system's health check. So we can discuss on that as well too. What all things we can add there for chassis.
Okay, sounds good. Actually, yeah.
So that's a separate process, right? The system health monitoring.
Yeah. Because currently PSU thermal control we have separate ones, but the other LEDs like the board LEDs we have to see where we can put it.
Okay.
System health monitoring is a daemon in PMON container or what?
Yes, I think so. I mean, I've not
we-
been part of the active discussion.
Yeah, that's a new that's a new discussion. Yeah, I think probably we should add to that.
I see. It seems to be Python, so it should be PMON. Yeah.
Yeah.
Okay.
Okay, so I made a note of it. So I think this pretty much kind of concludes.
Yeah. How about the FPD infra is expected to be catered as part of this chassis platform infra handling, right?
Which one? FPD?
What is FPD infra?
FPD upgrade of the firmware devices and all that.
Yeah, that's right. I think we scoped it out in the beginning, right? Not part of this particular design discussion. Yeah, I think the firmware upgrade is going to be and we will send another revision a little later after the initial thing is. I mean, these are the baseline, right? Then we definitely will cover the.
Yeah, I got it. I'm just trying to get an idea. It would be a part of this document, but will come later.
It come later because right now requirement we know is the upgrade will be completely a complete upgrade of the box rather than a firmware upgrade of particular process, right? Like that's the initial thinking. When you really want to upgrade only the particular component, we can take it as a separate HLD rather than this HLD, right? Because that could be a totally different process steps to do that. So that will be separate HLD. Yeah.
Okay, fine. If there would be a separate discussion, then that's fine. Yeah, I just want to get an idea as to how we intend. It's just issuing one command upgrade and expect the system to upgrade all the pending FPDs or what? Something on those lines.
We haven't thought much, so sorry.
Oh, sure. I was just asking. That's fine. If there is anything separate planned, or if we can plan, that would be good.
Yeah. So we'll put out that separately then.
Okay, got it. Thank you.
Because every system has a separate. Yeah, it's good to know how different system works when we can put a common things. Right now we know that one chassis, but it's good to know the other chassis and the operational model. At least the initial operational model for chassis is to get the chassis complete SONiC image running. Then we can upgrade the entire chassis with the SONiC running, and firmware also will be upgraded. There is no use case, at least right now, to upgrade the firmware alone. Then we can. So that will cover up initial process. Then we can go and upgrade a firmware by firmware.
Yeah, that's fine. Okay. And the third thing is OBFL. Did you cover it or plan to cover it?
UFL, because that one is a boot process. Boot specific, right? You're referring to that one, right?
So OBFL flash is maybe something like it's a flash available, and it is something like you can store the critical things that have happened on the system, a particular board temperature rising, or particular board exhibiting an issue with some access. So it's like it's something like for a later analysis or something. If you store there, because it is persistent, no matter you bring up the card n times, it's a persistent media. So not only platform, but the NOS can also leverage it for the purpose of storing critical, because when NOS is coming to know about various thermal, temperature, PSU state, it can dump a line or two about that occurrence onto that OBFL flash provided by the platform vendor. So around those things,
I see. So that not sure if it's a part of PMON, what we know, because those are like a hard drive specific when which syslog goes to which hard drive. I mean, which specific partition. If it goes to that that
No, no,
flash.
actually, it is not SSD or it's very much OBFL flash, where it's more like storing the critical data for later analysis. Or even if you are online on the system, you can try dumping the show OBFL, and it can dump the last 10-20 occurrences of what all happened onto that card.
I see. So basically,
So
I mean,
have we seen this on pizza boxes? Has this
sorry?
support been there? Have
No,
you seen?
this. So sorry, go ahead.
No, I was just wondering if this requirement could also be there for pizza boxes, right? The flash and.
Oh yeah, right, yeah.
So I was wondering if you've seen any implementation on SONiC for it, even in pizza boxes. It may not be chassis specific, but.
I mean, this seems to be something like the reboot cause. Where,
oh, like the reboot cause? Okay.
I mean, it feels like the reboot cause because there's a plugin for it where it could be like a hardware reboot cause for overheat or something.
Correct.
That's right. Yeah. So that will be a separate.
Yeah, reboot cause can come from the maybe it again vendor specific, but it could come from the FPGA registers of that card. But OBFL flash is much bigger compared to the specific set of registers board can maintain.
So from okay, I mean, if we sorry, I don't think we're covering here, but in any case, I think SONiC would be the way in which it can cover is probably everything. I mean, application talks to syslog. Today, that's what happens, and syslog decides which events. Then you can filter out the events. I mean, that's syslog rules, and the syslog can dump to this flash, OBS flash, and those syslog entries, so that application doesn't really know about but this flash or that flash. Application like thermal conductivity and fan D, which says that rising very sensitive alarms, and those alarms can be returned to the automatically via syslog D writing into the OBS's flash, right? So that could be the design for even for pizza box it will work. So not sure if it's only applicable in the supervisor can write it or line card can write it, but that can be there anywhere, right? Not necessarily very specific to one chassis or something. It can be any line card can have that kind of extra flashes.